Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week, and the topic today is all about troughs in the upper atmosphere, okay? And these are the features that dictate what goes on at the surface an awful lot of times. In fact, I had a professor at Penn State that told me one time, and I think this is a really accurate depiction, is that the surface weather map is more or less a reflection of what's going on up there, okay? What's going on up there sets up patterns of convergence and divergence, and so at the surface where we have divergence, we have highs, and when we have convergence, we have lows. So the surface weather, again, is a reflection of the forces going on up there. So let me go on ahead and put myself down here in the corner, and we're going to talk about the tilts of troughs, okay? They can be positive, negative, or neutral. A positively tilted trough has an axis that is oriented from northeast to southwest, okay? A neutrally tilted trough has an axis oriented north to south, and a negatively tilted trough has an axis that is oriented from northwest to southeast. But the ultimate question here is, why should we care? Okay, so here's an example of a positively tilted trough, okay? So the axis is oriented from northeast to southwest. And we've talked about the concept of vorticity, spin in the atmosphere, and when you have a sharply curved flow, that's where a vorticity maximum is going to be located. So we'll put the X right there. And then where the flow is curved the other way very sharply, we have a vorticity minimum, okay? And we'll depict that as an N, all right? So the distance between the X and the N is quite long. And as a result, the vorticity advection, okay, the positive vorticity advection, which leads to upward motion, is spread out over a long distance, okay? So you don't have a concentrated area of intense vorticity advection. It's spread out over a long distance. You can still get widespread precipitation in a situation like this, but it's not going to be, in most cases, all that terribly intense or concentrated, okay? Now, if we have a negatively tilted trough, like this one, from northwest to southeast, here's our vorticity maximum where the flow is curved sharply, and then where it's curved sharply the other way is the vorticity minimum. Now the distance between those two is much, much shorter. And so all the vorticity advection is concentrated in a relatively small area, and you end up getting intense upward motion over a smaller area. And in that region, you can end up getting intense rates of precipitation, sometimes even severe weather. And certainly today, the trough we were dealing with, no question, has a negative tilt to it. In fact, I've drawn in the axis there with that white dotted line. And again, ahead of the trough, we have very, very strong 500 millibar height falls. Behind it, very strong 500 millibar height rises. And notice how close together these two are, okay? So when you see a couplet like this that's covering a relatively short distance, that's telling you that all the vorticity advection is concentrated in a very, very small area and is going to be very, very intense. And indeed, that's what's going on up here across the northeastern U.S. at this particular time. All right, that is the bonus weather video for this Wednesday. I hope you found that at least mildly interesting. The next bonus video will be coming up on Friday. I may even do it tomorrow because I'll be traveling on Friday, so I might want to get that out of the road tomorrow. We'll see. And the next daily update, of course, coming up tomorrow. The one for today is already up. Okay, that's it for now. Have a great Wednesday evening, and we will talk to you again about this time tomorrow. Take care.